In the introductional presentation of encoders and decoders, I told you that we use decoders for the logic design like we did in case of multiplexers. Now what is the advantage of using the decoders in place of the conventional method of logic implementation? The first advantage is that we are going to use a single IC, but in conventional method we require so many gates and wires. So the space is reduced when we implement a logic by using the decoders, and also the cost. So instead of taking a random example, I have taken full adder to understand this topic. So this topic is all about the implementation of full adder by using a 3x8 decoder. So let's move to it. On the left hand side of your screen you can see the truth table for full adder. This truth table is being repeated so many times till now, so this must be a familiar truth table to you. In this we are having two numbers, A, B, both are single bit number, and we want to add them. Also we are taking the carry in account from the previous sum. This makes it full adder. I hope you know what is full adder. And the outputs are sum and carry output. I have already written the values for the sum and carry output that you can find by yourself by simply adding them and checking for the sum and the carry generated. Let's write down the minterms. This is your M0, M1, M2, M3, M4, M5, M6, M7. So we are having from M0 to M7 minterms for sum and our carry output. Let's write the functions fs for sum. It is equal to summation of M1. For sum it is high when the A, B are 0 and Cin is 1. The minterm M2, M4 and M7. So I can write M1, M2, M4, M7. Similarly, I can write the function for your carry output. It is summation M3, M5, M6, M7. So M3, M5, M6, M7. Okay. Now let's move to the most important part of this presentation. You can see a 3x8 decoder on the right hand side, and by 3 I mean we are having 3 inputs, and by 8 I mean we are having 8 outputs. Okay, now let's say I assume these 3 inputs are nothing but your first number A, your second number B, and the carry from the previous sum, which means A, B, C in. So depending upon the different values or different combinations, we are having the different outputs, because you know the functionality of the decoder. Let me tell you once again, if A is 0, B is 0, C in is 0, it means that this output will be considered, and this output is nothing but your M0, because when A, B, C are 0, 0, 0, we are having M0. Similarly, when it is 0, 0, 1, we are having M1, and when it is 1, 1, 1, we are having M7, and for all the cases. So I can write M2, M3, M4, M5, M6. This implementation is very simple because we are directly having our minterms as the output. So the only thing we need is to use the OR gate and take the output. So let's see how we have to do this thing. For the sum, we are having minterms 1, 2, 4, 7. So I will take 1, 2, 4 and 7. I will give it as the input to one OR gate, and the output will be your sum. Okay, very simple. Similarly, for your carry output, we are having minterms 3, 5, 6, 7. So I will take 3, 5, 6, 7. Use another OR gate and all the inputs will go in it, and the output will be your carry output. So this is how we do the combinational logic design by using the decoders, and this is the implementation of full adder by using the 3x8 decoder. We are having our 3 inputs A, B, C in, the first number, the second number, and the carry from the previous sum, the sum after adding A, B, C in, and the carry output after the addition. So this is all for this presentation, and we are done with our combinational part. In the next presentation we will start the sequential part. So see you in the next one.